Now here the question is, if A, B, C are three distinct numbers in HP, then which of the following is or are correct? Now we know that if A, B, C are in HP, then 1 upon A, 1 upon B and 1 upon C, they are in AP. We also know that if we multiply an AP with a number, it will still be an AP. So we'll multiply everything with A plus B plus C. So if we multiply everything with A plus B plus C, we can write A plus B plus C upon A plus B plus C upon B, A plus B plus C upon C. It will still be an AP. And if we subtract or add any number, it will still remain an AP. So what we'll do is, we'll subtract 2. So we can write B plus C minus A upon A, C plus A minus B upon B, and A plus B minus C upon C. It will also be an AP. That means this option A, it is correct. So this is your option A. And from this first part itself, if we subtract -1, then we can write B plus C upon A. Here will be C plus A upon B, and here will be A plus B upon C. It will still be an AP, and that's your part B. Now, if we look at this part D, then if we cross multiply, we can write AC minus BC, and it is equal to AB minus AC, or we can write 2AC equals AB plus BC, which means 2 upon B equals 1 upon C plus 1 upon A. That is ABC are an HP. That means this option D is also correct. Now what about this option C? For this option C, we are given A to the power 5 plus C to the power 5. Now we know that AM of mth power is greater than or equal to mth power of their AM if m doesn't lie between 0 and 1. So this is greater than or equal to A plus C upon 2 to the power 5, which is arithmetic mean of A and C. So this is A to the power 5, and arithmetic mean is always greater than or equal to their harmonic mean. So that means it is always greater than or equal to B to the power 5. So from here we can say A to the power 5 plus C to the power 5 is always greater than or equal to B to the power 5. That means this option C is also correct. So the correct options are A, B, C, D. Now here the question is, we are given this quadratic equation in which we have x square plus x plus 1 plus x square plus 2x plus 3, x square plus 3x plus 5 up to x square plus 20x plus 39, and is equal to 4500. Then the value of x is equal to what? Now we have 20 factors. So if we take x square, there will be 20x square plus, and what is the coefficient of x? It is 1 plus 2 plus 3 up to 20. So there will be 1 plus 2 plus 3 up to 20x, and then we have 1 plus 3 plus 5 up to 39, and this is equal to 4500. Now this is 20x square. Now this is n plus 1 by 2 x, and this is sum of first 20 odd natural numbers, and it is equal to n square. That will be equal to 20 square, and this is 4500. Now this 20, 20 and 20 will cancel. So this is 225. If we multiply this 2, we'll get this as 2x square plus 21x, and this is 40, and this is 450. So it will be minus 410 equals 0. Now we can write this as 2x square plus 41x minus 20x minus 410 equals 0. So this is 2x, x plus 41, and this is minus 20, x plus 41 equals 0. So value of x is either 10 or value of x is minus 41. So in this case, the only possible value of x is plus 10, and that's your option A. Now in this question, we are given that for triangle ABC, 81 plus 144 e to the power 4 plus 16 b to the power 4 plus 9 c to the power 4, it is equal to 144 ABC. Then which of the following is correct? So what we'll do is we'll consider these four numbers and we'll write their arithmetic mean, and it'll be 81 plus 144 e to the power 4 plus 16 b to the power 4 plus 9 c to the power 4 upon 4, and it will be greater than or equal to their geometric mean, which is 81 into 144 e to the power 4 into 16 b to the power 4 into 9 c to the power 4 whole to the power 1 by 4. Now we simplify this. This is 144 is 12 into 12. So there will be 9 into 16. Now this is equal to 4 to the power 4, 9 to the power 4, a to the power 4, b to the power 4, c to the power 4 to the power 1 by 4. So from here we can write 81 plus 144 a to the power 4 plus 16 b to the power 4 plus 9 c to the power 4 upon 4 will be greater than or equal to 36 ABC, or we can write 81 plus 144 a to the power 4 plus 16 b to the power 4 plus 9 c to the power 4. It is greater than or equal to 144 ABC. But in the question we are given that there is an equality sign, and we know that AM is only equal to GM if and only if all the numbers are equal. That means 81 must be equal to 144 a to the power 4, and it is equal to 16 b to the power 4, that is equal to 9 c to the power 4. So from here we can write this as a to the power 4 equals 9 by 16, b to the power 4 equals 81 by 16, and c to the power 4 equals 9. So from here we'll get a as root 3 by 2, b as 3 by 2, and c as root 3. That is, clearly we can see that a is less than b and is less than c. So sine a will be less than sine b and will be less than sine c. And since sine is an increasing function and all these values, they are positive, so it will lie in the first quadrant. So angle A will be less than angle B and will be less than angle C. So that means option A is incorrect and option B is correct. Now if we look at A square plus B square, there will be 3 by 4 plus 9 by 4. Now this is 12 by 4, 3, and which is C square. That means triangle ABC is a right angle triangle. So option D is also correct. So this triangle ABC, it is a right angle triangle, and these sides are AB and hypotenuse is C. Now area of this triangle will be half AB, and this value is going to be 1 by 2. A is root 3 by 2 and B is 3 by 2. So this value is 3 root 3 divided by 8, and that's your option C. So the correct options are B, C and D. Now the question is, we are given the series SR where R is greater than 0, then which of the following is or are correct? Now we are given that SR is this nested loop under root of R plus under root of R plus under root of R, and will continue up to infinite. Now this also is going to be SR. So we can write SR equals under root of R plus SR or SR square minus SR, it is equal to R. Now if we solve SR, we can write it is going to be 1 plus minus. We'll discard minus because this sum is going to be positive and it will be under root of 1 plus 4R divided by 2. Now the first option is S2, S6, S12 and S20 are in AP. So if we write S2, S2 will be 1 plus under root of 9 by 2. So there will be 4 by 2. So S2 is 2. S6 will be 1 plus, now this is 25, 5, 6. S6 is 3. S12 is 7 plus 1, 4. And S20 is 9 plus 1, 10, 10 by 5, 5, 2, 3, 4, 5, which is an AP. That means this option A, it is correct. Now for this option B, we need S4, S9 and S16. Now S4 will be 1 plus root 17 by 2. S9 it will be 1 plus root 37 by 2. And S16 it is 1 plus root 65 whole divided by 2, and all three of them are irrational. That means this option B is also correct. For this option C, if we look at 2SR minus 1 whole square, it is a 1 plus 4R, which is a linear term. That means this series 2SR minus 1 whole square, it is an AP. That means these three terms, S3, S4 and S5, they are terms of an AP. So option C is also correct. And option D is S2, S12 and S56. Now we already have S2. S2 is 2. S12 is 4. We need to find S56. Now S56 is 1 plus under root of 1 plus 4 into 56 whole divided by 2. Now 56 into 4 is 224. So it is 225, which is 15. So S56 is 8. So 2, 4 and 8, it is a GP. So that means option D is also correct. So the correct options are A, B, C, D. Now here the questions. We are given a sequence of numbers A1, A2 up to A1005 which satisfy A1 upon A1 plus 1 equals A2 upon A2 plus 3 equals A3 upon A3 plus 5 equals A1005 upon A1005 plus 2009. And we are also given that A1 plus A2 plus A3 up to A1005 is 2010. We need to find the nature of this sequence. Now, since they are equal, let us write, suppose it is equal to 1 by k. So for any AR, we can write AR upon AR plus 2R minus 1, it is equal to 1 by k, or AR k minus 1 equals 2R minus 1. So this AR will be 2R minus 1 upon k minus 1, where this k minus 1 is constant, and this 2R minus 1, it is nothing but an AP. So nature of this sequence is an arithmetic progression. Now if we look at this sum, which is A1 plus A2 plus A 1005, and this is 2010. So it is summation 2R minus 1, where R varies from 1 to 1005 upon k minus 1, and this is equal to 2010. Now sum of first odd natural numbers is equal to n square. So it will be equal to 1005 whole square, and this is equal to 2010 into k minus 1. Now if we cancel this, it will be simply 2, or k will be 1 plus 1005 by 2, or 1007 divided by 2. Now we need to find 21st term of this sequence. So we need to write A21, and A21 will be 41 upon k minus 1, and that will be 1005 into 2, which is 82 upon 1005. So answer to this question is, the sequence is an AP and whose 21st term is 82 upon 1005. Now we are given a function fn, which is 1 plus 1 by 2 plus 1 by 3 up to 1 by n, such that Pn fn plus 2 equals Pn fn plus Qn, where Pn and Qn are polynomial of least possible degree and Pn has leading coefficient unity. Then match the following column 1 with column 2. Now we can rewrite this as Pn, and this is fn plus 2 minus fn, and it is equal to Qn. Now fn plus 2 minus fn will be simply 1 upon n plus 1 plus 1 upon n plus 2, and it is equal to Qn. Now we can write this as 2n plus 3 Pn, and this is equal to n square plus 3n plus 2 into Qn. Now they're equal, and P and Qn must be least degree polynomial, and Pn has a leading coefficient unity. Now this Pn, it cannot be linear because n square plus 3n plus 2, it doesn't factorize to 2n plus 3. So this Pn will be at least quadratic. So this Pn will be quadratic, and therefore this Qn will be a linear term. Now it says Pn is a polynomial with leading coefficient 1. So we can write this Pn as n square plus an plus b, and this Qn will be Cn plus d. Now we put the value of Pn and Qn, we can write 2n plus 3 into n square plus an plus b, and it is equal to n square plus 3n plus 2 into Cn plus d. Now we compare the coefficient of n cube, we'll get 2n cube equals Cn cube. That means value of C is 2. If we compare the coefficients of n square, now on the left hand side we'll get n square as 3n square plus 2an square, and here we'll get 3cn square plus dn square. Now C is already 2, so we can write 2a minus d, it is equal to 3. So that's our first equation. Now we compare the coefficient of n, we can write 3an plus 2bn, and it will be equal to 3dn plus 2cn. Now again we put value of c as 2, so we can write 3a plus 2b equals 3d plus 4. And if we take its constant term will be 3b equals 2d. So we have 3 equations and 3 unknowns. Now we need to find the value of a, b and d. Now what we'll do is, we'll put the value of b here. So you can write 3a plus 2 into 2d by 3 minus 3d equals 4, or 9a plus 4d minus 9d equals 12, or 9a minus 5d equals 12. So now we have two equations and two unknowns. 2a minus d minus 3. So if we multiply it with 5, we can write 10a minus 5d equals 15. If we subtract first from second, we'll get a equals 3. And if we put a as 3, we'll get d as 3. And if we put d as 3, we'll get b as 2. So value of a is 3, value of b is 2, value of c is 2, and value of d is 3. So now from here we can write Pn equals n square plus an plus b. An plus b will be 3n plus 2, and Qn will be Cn plus d, and Cn plus d will be 2n plus 3. A simpler way to solve this question would have been if we would have considered n square plus an plus b into 2n plus 3, and it is equal to Cn plus d into n square plus 3n plus 2. Now we can rewrite this as n square plus an plus b into 2n plus 3, and this is Cn plus d, and it is n plus 1 into n plus 2. Now 2n plus 3 cannot be equal to n plus 1 or n plus 2. That means this 2n plus 3 must be equal to Cn plus d. So clearly Qn will be 2n plus 3, and this expression Pn will be equal to this quadratic. So this Pn will be simply n square plus 3n plus 2. So it is much faster way to find the value of Pn and Qn. Now we'll start solving the options. Now this first part is A. You need to find this summation. N varies from 1 to m Pn minus 2 upon n. Now Pn minus 2 upon n will be simply summation n plus 1 to m, and will be simply n plus 3, which is an AP. Now for this AP, number of terms is m, first term is 4, and last term is n plus 3. So its sum will be m by 2, 4 plus m plus 3. So there will be m plus 7 by 2. That means this option A, it matches with S. So this option A, it matches with S. Next one is Qn minus 3 by 2. So if we look at Qn minus 3 by 2, this is nothing but n. And if we take this summation from n varies from 1 to m, this is nothing but m plus 1 by 2. That means this B, it matches with P. So this B, it matches with P. Now for the next one, we need Qn square, and this Qn square will be 4n square plus 12n plus 9. Now Pn plus Qn square minus 11, that will be 4n square plus n square. So there will be 5n square plus 15n plus 11 minus 11, and we need it divided by n. So there will be 5 into n plus 3. So if we find this summation, it is the same summation n plus 3, is just that we have additionally this 5. So it will be this 5 and this first answer, which is m plus 7 by 2. That means this C, it matches with Q. This C, it matches with Q. And for this D part, we need to find Q square n minus Pn minus 7. Now we subtract it, we'll get 3n square, this is plus 9n plus 7 minus 7 will cancel, and if we divide it with n, we'll get this as 3n plus 3, which again is same summation. So if we take this summation, so it will be this 3m plus 7 by 2. So that means this D, it matches with R, and that is the answer to this question. Now in the next question we are given that under root of 1 1 1 1 1 2n times minus 2 2 2 2 n times, it is equal to p p p p n times, then find the value of p. Now we know that p p p and p, it is equal to p plus 10p plus 10 square p, and goes all the way up to 10 to the power n minus 1 p. Now this is p and this is 10 to the power n minus 1 upon 9. So this number is p into 10 to the power n minus 1 upon 9. Now if we put p as 1 and n as 2n, we'll get this first number. So we can write under root of 1, and this is 10 to the power 2n minus 1 upon 9 minus, and here p is 2 and n is n, so there will be 10 to the power n minus 1 upon 9, and it is equal to p into 10 to the power n minus 1 upon 9. Now we can write this as under root of 10 to the power 2n minus 2 into 10 to the power n plus 1 upon 9, and this is p into 10 to the power n minus 1 upon 9. Now this is a square plus b square minus 2ab, so there will be 10 to the power n minus 1 upon 3, and this is p into 10 to the power n minus 1 upon 9. Now I will cancel, so clearly value of p is 3. So answer to this question is value of p is 3. Now the question is, let a1, a2, a3, an be real numbers in AP such that a1 is 15 and a2 is an integer, and we are given that sum of squares of first 10 numbers is 1185, and if Sn is r varies from 1 to n and maximum value of n is n, for which Sn is greater than Sn minus 1, find the value of n minus 10. Now we are given that a1 is 15, and we are also given that summation ar square, where r varies from 1 to 10, it is 1185. Now its general term will be 15 plus r minus 1d whole square, and this is 1185. Now we can write this as summation r varies from 1 to 10 225 plus r minus 1 square into d square plus 30 r minus 1 into d, and this is 1185. Now we take this summation, this first term will be 2250. Now this is 0 square plus 1 square up to 9 square. So this is 1 square plus 2 square 9 square d square, and this is 30, and this is 0 plus 1, so it is 1 plus 2 up to 9 into d, and this is 1185. Now this is n plus 1, 2n plus 1 by 6. So this is 9 into 10, 19 by 6 d square, plus this is 30, and this is n plus 1 by 2 into d, and plus this is 2250 minus 1185, which is 1065 equals 0. Now this is 3, this is 5, this is 5. Now we'll divide everything with 15. This is 71. So we'll get this equation as 19d square plus 90d plus 71 equals 0. So we can write this as 19d square plus 19d plus 71d plus 71 equals 0, or 19d plus 71 into d plus 1 equals 0. So value of d is either minus 71 by 19, or value of d is minus 1. Now it says a2 is an integer. So if a2 is an integer, that means we cannot take d as minus 71 by 19. So the only possible value of d here is minus 1. So for this arithmetic progression, a1 is 15 and common difference is minus 1. We need to find the condition that Sn is greater than or equal to Sn minus 1. Now Sn is t1 plus t2 up to tn, and this is t1 plus t2 up to tn minus 1. That means this tn, it should be greater than or equal to 0. So we need to find maximum value of n for which tn is greater than or equal to 0. Now tn is 15 plus n minus 1 into d. It is greater than or equal to 0, or n minus 1 is less than or equal to 15, or n is less than or equal to 16. So the greatest value of n is 16, and n minus 10, it is nothing but 6. Now the question is, find the sum of this series, which is 1 plus 1 by 2 plus 1 by 3, 1 by 2 square, 1 by 2 into 3, 1 by 2 cube, 1 by 3 square, 1 by 3 into 2 square up to infinite, where the terms are reciprocals of positive integers whose only prime factors are 2's and 3. Now we know that such a series can be made using the product of these two series, 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to infinite into 1 plus 1 by 3 plus 1 by 3 square up to infinite, and both of them, they are infinite GP with r less than 1. So sum of this first GP is a upon 1 minus r into sum of this second GP is a upon 1 minus 1 by 3. Now this is 2 into, and this is 3 by 2. So solve this series is simply 3, and that is the answer to this question. Now here the question is, if x, y, z are real, and we are given that 4x square plus 9y square plus 16z square minus 6xy minus 12yz minus 8zx equals 0, then x, y, z are in. Now if you look at the series, this is 2x square plus 3y square plus 4z square minus, this is 2x into 3y minus 3y into 4z minus 4z into 2x equals 0, which is this standard series a square plus b square plus c square minus ab minus bc and minus ca equals 0. Now if we multiply it with 2, we can write 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca equals 0. Now if we take ab together, bc together and ac together, we can write this as a minus c square plus b minus c square plus c minus a whole square equals to 0. So the only result we get here is a equals b equals c. So if we have this situation where non-zero numbers a, b and c are such that a square plus b square plus c square minus ab minus bc minus c is 0, then the result is a must be equal to b must be equal to c, and it's an important result which has been extensively used by JEE Advanced. So in this case also, this is a square plus b square plus c square minus ab minus bc minus c equals 0. That means from here we get 2x equals 3y equals 4z, and suppose this is equal to k. Now k by x equals to k by y equals 3 and k by z equals 4. Now 2, 3, 4, they are in AP. So k upon x, k upon y, k upon z, they are in AP. We can divide everything with k. So 1 upon x, 1 upon y, 1 upon z, they are in AP. That means x, y and z, they are in HP. So answer to this question is this option C. Now here the question is, let A1, A2, A3 up to AN be an AP with common difference D, and we have defined BK as the series AK plus AK plus 1 up to AK plus n minus 1. Now this series, it goes from 0 to n minus 1. So number of terms in this series is simply n. So BK basically is sum of n terms of this series. We can write this as n by 2, and it will be AK plus n minus 1. Now this is n minus 2. Now AK is kth term, so it will be A1 plus k minus 1d, and this AK n minus 1 will be A1 plus k plus n minus 2d. Now we can take k minus 1d and k minus 1d here, so it will be this n by 2 A1 plus, we also have this A1 and then 2 times k minus 1d, and what we are left with is n minus 1d. Now A1 plus n minus 1d is nothing but An. So we can write this as n by 2 A1 plus An plus 2 k minus 1 into d, which is your option C. So that's your option C. Now we'll also need to find summation Bk. So that's your Bk, and we need to find summation Bk where k varies from 1 to n. Now if we take this summation, we can write this summation Bk as, now it is n by 2 A1 plus An into n, since it is a constant term, plus, and then we'll multiply this n by 2, so we'll have this nd, and then summation k minus 1 where k varies from 1 to n, so it will be this n square by 2 A1 plus An, and here will be this nd, and this series is 0 plus 1 up to n minus 1, which is n minus 1 n by 2. What we'll do is we'll take n square by 2 common, and then we'll have A1 plus An plus n minus 1d. Now A1 plus n minus 1d again is An, so there will be n square by 2 into 2An. So summation Bk will be simply n square an, and that's your option A. So the correct options are A and C. Now here the question is, if A1, A2 up to A21 are in AP and sum of this AP is 693 and sum of odd terms of this AP is 5k plus L, then k plus L upon 25 equals to what? Now we know that A1 plus A2 plus A3 up to A21, it is equal to 693. Now we also know that its middle term, it will be 21 plus 1 divided by 2, and that is 11th term. So A1 plus A21 by 2 equals A2 plus A20 by 2, and it will be equal to A11. We can make these pairs. So we'll form 10 pairs of A1 plus A21, and that will be equal to 2 times A11 plus A11, and that is equal to 693. So we'll get 21 into A11 equals 693. So value of A11 is 33. Now we need to find sum of this series. A1 plus A3 plus A5 up to A21. So here we have 11 terms, and middle term will be its 6th term, which again is A11. So it will be 5 times A1 plus A21 plus A11, and this is 2 times A11, so there will be 11 times A11, and that is 363. Now we divided 5, it will be 35, 2, so we can write this as 72 into 5 plus 3. We have expressed it in the form 5k plus L, where the value of k is 72 and value of L is 3. Now it is asking for value of k plus L upon 25. So there will be 75 upon 25, 3. So answer to this question is simply 3. Now here the question is, we have defined Nm as this product n minus m, n minus 2m to n minus km, where k is the greatest number such that n is greater than km. We need to find the value of 72, 8 and 18, 2. Now if we look at 72, 8, it will be 72, 72 minus 8, 72 minus 16, 24, and you go up to 72 minus 64, and here will be 18, 18 minus 2, 18 minus 4, and 18 minus 16. Now this is 72. 72 minus 8 is 64. 64 minus 8 is 56. And this is 8. This is 16. So we have all the numbers 8, 8 into 2, 8 into 3, up to 8 into 9. And here we have 2, 4, and this is 14, 16, and 18. Now here we'll take 8 common from each term. So altogether there are 9 terms. So it will be 8 to the power 9 into factorial 9, and here we'll take 2 common from each term. So it will be 2 to the power 9 factorial 9 Now factorial 9 and factorial 9 will cancel. It will be equal to 4 to the power 9, and that's your option A. Now here the question is, we are given two series. The first series is the series A, which is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, and it goes up to 1 upon 2n minus 1 minus 1 upon 2n, and then we have the series B, which is 1 upon n plus 1 plus n plus 2 to 1 upon 2n. We need to find the value of 19a plus 8b upon 2a plus b. Now what we will do is, we add 1 by 2 and we will subtract 1 by 2. We will add 1 by 4 and we will subtract 1 by 4, and we will do it for all the even terms. So we can write this A as 1 plus 1 by 2 plus 1 by 3 up to 1 by 2n, and then minus 2 into 1 by 2 plus 1 by 4 up to 1 by 2n. Now this is 1 plus 1 by 2 plus 1 by 3 up to 1 by 2n, and minus, we will multiply this 2 here, 1 plus 1 by 2 up to 1 by n. So from this series we have removed first n plus 1 terms. So this is equal to 1 upon n plus 1 plus n plus 2 up to 1 upon 2n, which is nothing but b. So from here we have proved that a equals b, and if a equals b, then here it will be 27a upon 3a, and this is 9. So answer to this question is 9, which is option C. Now here the question is, let a1 be unequal to 0, and for n greater than 1 we are given that an equals n upon a n minus 1. Then we need to find the value of a1 into a2 up to a10. Now basically this is product of two consecutive terms. We can write an into an minus 1, ab equal to n. Now if we put n as 2, we can write a2 into a1 will be simply 2. If we put n as 4, we'll write a4 into a3 will be equal to 4. In the same way, a6 into a5, this is 6, and in the end we'll have a10 into a9, and will be equal to 10. We multiply all these terms, we'll get this product, a1 into a2 into a3 up to a10, and there will be 2 into 4 into 6 into 8 into 10, which is 2 to the power 5 into factorial 5, and that is 32 into 120, and which is 3840. So value of this product is 3840. Now here the question is, our term of series can be written as AR equals FR minus FR minus 1, and Sn is summation AR, which is Fn minus F0, and S infinite is limit n tends to infinite Sn. Now first we need to find value of this summation R varies from 1 to infinite 4r minus 1 pi to the power r upon r square plus r. What we'll do is, we can write this as this summation r varies from 1 to infinite. Now we can write this as 5r minus r plus 1 upon r into r plus 1 into 5 to the power r, and will be this summation r varies from 1 to infinite. Now we multiply them, this r and r will cancel, we get 5 to the power r plus 1 upon r plus 1 minus, now here r plus 1 will cancel, we get 5 to the power r upon r. Now if we put r as 1, we'll get this as 5 square upon 2 minus 5 upon 1 plus 5 cube upon 3 minus 5 square upon 2 up to infinite. Now these successive terms, they'll cancel. But the problem here is we have this GP whose common ratio is 5, which is greater than 1. So this series is not going to converge. So even though the terms are cancelling, we have this telescopic summation, but this telescopic summation, it doesn't converge. Now proper way to solve this question would have been, rather than finding sum up to infinite, we'll find sum of n terms. Now sum of n terms will be 5 square by 2 minus 5 upon 1 plus 5 cube by 3 minus 5 square upon 2 up to 5 to the power n plus 1 upon n plus 1 minus 5 to the power n upon n. Now these terms, they'll cancel. So in the end, we'll have this Sn as 5 to the power n plus 1 upon n plus 1 minus 5. Now if we take this limit n tends to infinite, Sn will be this limit n tends to infinite 5 to the power n plus 1 upon n plus 1 minus 5. Now this is infinity upon infinity form. We can use L'Hopital's rule. So we can write this limit n tends to infinite Sn, it will be this limit n tends to infinite 5 to the power n plus 1 ln 5 upon 1 minus 5. Now 5 to the power infinite is infinite. So this series, it doesn't converge. So we do not have a limiting value of sum. So answer to this first question is this option D, none of these. Now for this second question, we are given that cos 1 minus 1 summation sin n, where n varies from 1 to 50 plus sin 1 summation cos n, n varies from 1 to 50. Now we'll rearrange it a bit. We'll take these terms together. So we can write this as this summation n varies from 1 to 50 cos 1 sin n plus sin 1 cos n and minus this summation n varies from 1 to 50 sin n. Now this is sin a cos b plus cos a sin b, sin a plus b. So we can write this as this summation n varies from 1 to 50 and this is sin n plus 1 and this is minus sin n. Now if you put n as 1, it will be sin 2 minus sin 1 plus sin 3 minus sin 2 and we will go all the way up to sin 51 minus sin 50. Now these successive terms, they'll cancel. So we'll get this result as sin 51 degrees minus sin 1 degrees, and that's your option C. So answer to the second question is this option C. And then we have this third question where it is 3 into factorial 3 plus 4 into factorial 4 up to 50 terms. Now its general term will be r plus 2 into factorial r plus 2, where r varies from 1 to 50. Now we can write this as r plus 3 minus 1 factorial r plus 2. R plus 3 into factorial r plus 2 is factorial r plus 3 and minus factorial r plus 2. Now we write Sn. Now when r is 1, this is factorial 4 minus factorial 3. Then it will be factorial 5 minus factorial 4. And in the end, we'll have factorial 53 minus factorial 52. All these successive terms, they'll cancel. So we'll get this as factorial 53 minus factorial 3. Or this is factorial 53 minus 6. Now they have expressed it in the form factorial a minus b. So this a is 53 and b is 6. Now we need to find the value of a minus b. Now 53 minus 6 is 47, which is your option C. Now here the question is, the balls are arranged in row to form an equilateral triangle. The first row contains 1 ball, second row contains 2 balls, the third row 3 balls, so on and so forth. So for any nth row will contain n balls. Now here we have formed an equilateral triangle. Now it says if we add 669 balls, then we can form a square and each of its sides that contain 8 balls less than each side of the triangle did. So if there are n balls in the sides of a triangle, in this square there will be n minus 8 balls in any one side. Now first we'll count total number of balls in this equilateral triangle. So it will be this 1 plus 2 plus 3 up to n, and then we are adding 669 balls, and then number of balls in this square will be simply n minus 8 square. Now this is n plus 1 by 2 plus 669, and this is equal to n square plus 64 minus 16n, or we can write n square plus n plus 669 minus 64. 605 into 2, 1210, and there will be 2n square minus 32n, or we can write n square minus 33n minus 1210 equals 0. Now this is 11 into 11 into 10. Now this is 5 into 2, 55 minus 22. So we can write n square minus 55n plus 22n minus 1210 equals 0. So from here, the value of n we get is 55. So n equals 55. So number of balls in the sides of an equilateral triangle will be 65. So this C matches with P. Now number of balls inside of square is n minus 8. Now 55 minus 8 is 47. So this D, it matches with S. Now initial number of balls is n plus 1 by 2. So it will be 55 into 56 by 2. So this is 28, which is 14 into 110, so which is 1540. So this A, it matches with Q. And number of rows forming the equilateral triangle, number of rows is again equal to n, and which is 55. So this also matches with P. And that is the answer to this question. Now here the question is, if A, B, C are positive integers forming an increasing GP and B minus A is a perfect square of a natural number and log a base 6 plus log b base 6 plus log c base 6 equals 6. And find the value of a plus b plus c minus 105. Now from this log equation we can write log abc to the base 6 equals 6, or abc is 6 to the power 6. Now if ABC forms a GP, then B square equals AC. So we can write B cube equals 6 square cube. So value of B is simply 36. Now it says B minus A is a perfect square. So basically 36 minus A, it is n square, or this A is 36 minus n square. Now we have to make it a perfect square. Now the closest perfect square is 25, for which A should be 11. But this C, it has to be an integer, so that means B square by A, it must be an integer. So 36 into 36 by A, it should be an integer. So A cannot take the value 11. Now next one could be 16. For it, value of A is 20. Again, it is not possible. Then we have 3 square 9, and for which value of A is 27. Now if we take value of A as 27, this is, so from here we can say value of A, it should be 27. Now A is 27, B is 36, and C is 48. We need to find the value of A plus B plus C minus 105. This is 27 plus 36 plus 48 minus 105, which is 6. So answer to this question is simply 6. Now here the question is, if A1, A2, A3, An are in HP and Fk, this summation R varies from 1 to n AR minus AK. Now this is sum of first n terms, and let this sum be S, which is constant, so it will be this S minus AK. Now it says then A1 upon F1, A2 upon F2, and An upon Fn are in what? Now if we write AK upon Fk, it will be AK, and this is S minus AK. We can write this is 1 upon S minus AK minus 1. Now we know that A1, A2, AK, An, they are in HP, then the reciprocal 1 upon A1, 1 upon A2, 1 upon AK, 1 upon An will be an AP. We will multiply it with S, so we can write S upon A1, S upon A2, S upon AK, S upon An will be an AP, and if we subtract 1 also, it will still be an AP. So then S by A1 minus 1, S by A2 minus 1, S by AK minus 1, S by An minus 1 will be an AP, and its reciprocal 1 upon S A1 minus 1, 1 upon S A2 minus 1, 1 upon S AK minus 1 will be an HP. So this resulting sequence, it is an HP, which is your option C. Now here the question is, if ABC are in HP, then which of the following is or are correct? Now if ABC are in HP, then 1 upon A, 1 upon B, 1 upon C, they are in AP. Multiplying everything with A plus B plus C will still be an AP. So A plus B plus C upon A plus B plus C upon B, and A plus B plus C upon C LB and AP, and we'll subtract 2 from it. So we get B plus C minus A upon A, C plus A minus B upon B, A plus B minus C upon C, LB and AP, and it's reciprocal, A upon B plus C minus A, B upon C plus A minus B, C upon A plus B minus C, LB and HP. So that means this option A, it is correct. If we look at this option B and if we simplify it, so that's your option A. We can write 1 upon B minus 1 upon B minus A, and is equal to 1 upon B minus C minus 1 upon B. So it will be B minus A minus B upon B into B minus A, and this is B minus B plus C upon B into B minus C. Now this B and B will cancel. These are also going to cancel. So we get minus A into B minus C will be equal to C B minus A. So minus AB plus AC is equal to BC minus AC, or 2AC equals BC plus AB, or 2 upon B equals 1 upon A plus 1 upon C. That means ABC are in HP. So that means this option B is also correct. If we check this option C, we are given that these numbers, they are in GP. So we can write B by 2 square, it is equal to A minus B by 2 and C minus B by 2. So it will be this B by 2 square, and this is AC minus BC by 2 minus AB by 2 plus B by 2 square will cancel. Again we get 2AC equals BC plus AB, or 2 upon B equals 1 upon A plus 1 upon C. That means ABC are in HP. So option C is also correct. Now if we look at this option B, we can get it from here itself. In this step, rather than taking minus 2, we'll take minus 1. So if we take minus 1, we'll get B plus C upon A, C plus A upon B, and A plus B upon C. They are in AP. So the reciprocal, A upon B plus C, B upon C plus A, C upon A plus B. They are in HP. That means this option D is also correct. So the correct options are A, B, C, D. Now here the question is, 3 numbers in AP with common difference D are removed from first n natural numbers, and the average of remaining numbers is found to be 43 by 4. Then ordered pair n and D can be. So we have first n natural numbers 1, 2, 3 up to n, and from these n numbers we have removed 3 numbers which are in AP, and suppose they are A minus D, A, and A plus D. It says the average of remaining numbers is found to be 43 by 4. Now we know that sum of all these numbers, it is n plus 1 by 2 minus sum of these 3 numbers, which is 3a, and for their average we have to divide them with n minus 3, and this average, it is equal to 43 by 4. We can write this as n square plus n minus 6a upon 2n minus 3, and it is equal to 43 by 4. Now this 2 will cancel. We can write this as 2n square plus 2n minus 12a, and this is 43n minus 129. So we can write this as 2n square minus 41n plus 129 minus 12a equals 0. Now we can write this a as 2n square minus 41n plus 129 divided by 12. Now this a it has to be an integer. Now we can also write this as a. We'll take this n common, and then it will be 2n minus 41 plus 9, and then we write this as 120. So it will be this whole divided by 12 and plus 10. It should be an integer. Now we need to find value of n, for which this a, it is an integer. Because a minus d, a and a plus d, they come from natural numbers. So this a, it has to be a natural number. Now there are two values of n given in the question. Either n can take the value 19 or 23. So first we'll check for n equals 19. Now if we put n as 19, it will be this 19, and then this is 38 minus 41. So that will be minus 3 plus 9 divided by 12 plus 10. Now we can cancel 3. So that will be minus 19 plus 3. Minus 16. Minus 16 by 4 is minus 4 plus 10. So value of a is 6. So one of the solution is when the value of n is 19, and when n is 19, value of a is 6. Now since we have a minus d, that means value of d, it should be less than 6. So for 19, we can choose any value of d which is less than 6. So one of the option is 19.5, another option is 19.2. We cannot choose 19.8. Now what if n is 23? If we put n as 23, we'll get this as 23, and this is 46 minus 41, 5, plus 9 divided by 12 plus 10, which is not an integer. So n is equal to 23 is not a solution. So the correct options are A and B. Now the question is 4 different integers form an increasing AP. One of these numbers is equal to sum of squares of other 3 numbers. Then which of the following is correct? Now suppose the numbers are a minus d, a plus d, and a plus 2d, where d is greater than 0 since it is an increasing AP. And the reason we have taken this as a minus d, a and a plus d, because we have to use sum of squares of other 3 numbers. So we are given that a plus 2d is equal to a minus d square plus a square plus a plus d whole square. Now this is a plus 2d. Now this is a square plus a square plus a square. There will be 3a square and then plus 2d square minus 2ad plus 2ad will cancel. So we can write this as 2d square minus 2d plus 3a square minus a equals 0. Now if we solve for d, we can write d equals 2 plus or minus under root of b square, which is 4, and then minus 8, 3a square minus a whole divided by 4. Now we can cancel 2. We can write d 1 plus minus under root of 1 minus 6a square plus 2a whole divided by 2. In the question, we need integers. That means this d, it must be an integer, and this 1 minus 6a square plus 2a square, it must be greater than 0, and it must also be a perfect square. Now if we simplify this, we can write 6a square minus 2a minus 1 is less than 0. The critical points are 2 plus minus under root of 4 plus 24 whole divided by 12, and this is 1 plus minus under root 7 divided by 6. So here we have two values of a, 1 minus root 7 by 6 and 1 plus under root 7 by 6. This is plus, minus and plus. So from here, the only integral value of a possible in this region is a equals 0. And if we put a equals 0, we'll get value of d as 1. Once we have the value of A and B, we can write all the four numbers. So the four numbers are -1, 0, 1 and 2, and product of all numbers is simply 0. Now what is the sum of all these numbers? Sum of these four numbers is simply 2. And what is the common difference of four numbers? We know that value of D here is 1, and that's your option A. So the correct options are C, D and A. And the question it says the numbers A, B, C are between 2 and 18. So we have three numbers A, B and C, and they lie between 2 and 18 such that this sum is 25. So that means A plus B plus C, it is 25. The numbers 2A and B are consecutive terms of an AP. That means twice A equals B plus 2, and the numbers B, C and 18 are consecutive terms of a GP. That means C square equals 18B. We need to find the value of ABC. Now we have three equations and three unknowns. Now first what we'll do is we'll put the value of 2A here. We'll multiply it with 2. So we'll write 2A plus 2B plus 2C equals 50. Now 2A is B plus 2. So there'll be 3B plus 2C equals 48. Now 18B is C square. So we'll multiply this with 6. So we can write 18B plus 12C, and this is 48 into 6, which is 288. Now 18B is C square. So we can write C square plus 12C minus 288 equals 0. Now this is 8 into 6 into 6. So we can write this as C square plus 24C minus 12C minus 288 equals 0. C plus 24 minus 12, and this is C plus 24 equals 0. So from here, the positive value of C we'll get is C equals 12. Once we have the value of C, we can write B. Now this B is C square by 18. So there will be 12 into 12 divided by 18. So value of B is 8. And if we put the value of B and C in this first equation, we'll get value of A as 5. So value of A is 5. Now first question is we need to find the value of A, B, C. Now A into B into C is 5 into 8 into 12, which is 10 into 4 into 12, 480, and that's your option D. Now the next question is we need to discuss nature of roots of this equation. So for this we'll calculate D, which is B square minus 4AC. Now B square is 64 minus 4AC is 4 into 12 into 5 minus 240, which is less than 0. So roots are imaginary. And it says if A, B, C are roots of this cubic equation, then find the value of R. Now basically if we write S2 for this equation, then AB plus BC plus CA, it is equal to R. So this R will be 12 into 8, 96 plus 12 into 5, 60 plus 5 into 8, 40, and there will be 196, and that's your option B. So correct options are D, C and B. Now here the question is, natural numbers are divided into sets 1, 2, 3, 4, 5, 6. So in the first set we have this element 1, in the second set we have this element 2, in the third set we have this element 4. Now in the first set we have one element. Now in these two sets we have 3 elements. In first 3 sets we have 6 elements. In the fourth set, which you can write 7, 8, 9, 10, we have 10 elements. So last element of any set is going to coincide with number of elements from 1 to that number. So if we talk about this n minus 1 set, then this last element in n minus 1 set, it will be sum of all the numbers in all the sets till this set. So it will be 1 plus 2 plus 3 up to n minus 1. So it will be n minus 1 by 2. So first element of this nth set, it will be n minus 1 by 2 plus 1, or simply n square minus n plus 2 whole divided by 2. And last element in this set n, which is the nth element, will be n plus 1 by 2, and number of elements will be simply n. That says sum of element in any set. Now first we need to find sum of element in any set. So sum of element in this nth set will be simply n by 2 and then a plus l. Now a plus l will be n square minus n plus 2 by 2 plus n square plus n by 2. Now this n and n will cancel. Now this is 2n square plus 2. So we'll get this as n by 2 into n square plus 1. Now S50 will be simply 25, and this is 2501, which is 62525. And that's your option B. Now the next question is last element in 2007th set. Now last element in nth set, it is n plus 1 by 2. So last element in 2007 set, it will be 2007 into n plus 1 by 2. So there will be 2008 whole divided by 2. So it is 1004, and this is 2015028, and that's your option A. And finally, it says the average of middle two elements of 2008 set is lambda. Now we know that in any set we have numbers in AP, and in an AP the average of numbers equidistant from beginning and end, they are same. So average of middle two elements of 2008 set will be same as average of its first element and its last element. Now if we add them, this n square will cancel, so this average will be simply n square plus 1, this whole divided by 2. Now we need this average for n equals 2008, so there will be 2008 whole square plus 1 divided by 2, and we need its integral value. Now this is 2016032.5, so its integral value will be 2016032, and that's your option C. Now here the questions, we are given the series Sn, which is 1 plus 1 by 2 plus 1 by 3 up to 1 by n. We need to find this value S1 plus S2 up to Sn minus 1. Now what we'll do is, rather than finding the sum, we'll find the sum of S1 plus S2 up to Sn, thereby getting a better symmetry rather than taking n minus 1. So we can write this as 1 plus 1 plus 1 by 2, 1 plus 1 by 2 plus 1 by 3, and we'll continue up to 1 plus 1 by 2 plus 1 by 3 up to 1 by n. We have this one n times, so we can write this as n upon 1, and then we'll have n minus 1 by 2, n minus 2 by 3, and in the end we'll have n minus 1 by n. Now what we'll do is, we'll take these terms of n together and we take n common, so it'll be 1 plus 1 by 2 plus 1 by 3 up to 1 by n, and then we'll have minus 1 by 2, minus 2 by 3, minus 3 by 4 up to minus n minus 1 by n. And what we'll do is we'll add 1 to each term, and we have added this 1 n minus 1 times, so we'll add minus n minus 1. So we'll get the series as S1 plus S2 plus Sn minus 1 plus Sn. It will be n into Sn. Now this is plus 1 by 2, plus 1 by 3, plus 1 by 4, plus 1 by n. And we'll add 1 and we'll subtract 1. So this again will be Sn, and here will be simply minus n. This Sn and Sn will cancel. So sum of the series S1 plus S2 up to Sn minus 1 will be simply Nsn minus n. And that's your option A. Now the question is, if this equation has 4 positive roots, then the value of A is. Now if it has 4 positive roots, alpha, beta, gamma and delta, then we can write S1 as alpha plus beta plus gamma plus delta, and it is equal to 4. And if we take the arithmetic mean, we can write alpha plus beta plus gamma plus delta by 4. It is equal to 1. So the arithmetic mean is 1. If we write there S4 is alpha beta gamma delta, and this value it is 1. And if we write their geometric mean will be alpha beta gamma delta to the power 1 by 4, which is also 1. So in this case, arithmetic mean is equal to their geometric mean, which simply means that all the 4 roots, they must be equal. So alpha must be equal to beta, must be equal to gamma, and it must be equal to delta, and each of the value is equal to 1. We need to find A, and basically we can write S2 as this cyclic summation alpha beta, and it will be equal to A. Now how many terms we have, which are of the type alpha into beta? So all these 4 we have to select n into, so it will be simply 4C2. So we'll have 4C2 terms, and the product of each term is simply 1. So this value will be simply 6. So value of A is 6, and that is the answer to this question. Now here we are given 2 series. One of them is A, which is 1 square by 1 plus 2 square by 3 plus 3 square by 5 up to 1001 square by 2001. And then we have this B, which is 1 square by 3 plus 2 square by 5 up to 1001 square by 2003. First we need to find A minus B. Now if we write A minus B, we'll take these terms together. So it will be this 1 plus, and here will be this 2 square minus 1 square by 3, and then 3 square minus 2 square by 5, and here we'll have 1001 square minus 1000 square by 2001, and then minus 1001 square upon 2003. Now this is 1. This is A plus B into A minus B. So there will be 3 upon 3. This is 5 upon 5. And here it is 2001 upon 2001 minus 1001 square upon 2003. So each of this term, it is equal to 1. So this is 1 plus 1 plus 1, 1001 times. So we can write A minus B as 1001 minus 1001 square upon 2003. Now we can take 1001 common, and it will be 2003 minus 1001 divided by 2003, Now this value, it is equal to 500.7498. Now option C is A minus B is 500.74. Now can we take it as 0.74 not? It is little dicey. So we are going to leave it open-ended. Definitely it is not 500.94. Now its greatest integer function is 500. Now integer closest to A minus B is 501. So the correct options are A and B. This C, it is also incorrect. Even if we round off, it will be 0.75, not 0.74. Now here we are given a sequence of real numbers such that an plus 1 equals an plus under root of 1 plus an square and a0 equals 0. If limit n tends to infinite, an upon 2 to the power n minus 1 is k by pi, we need to find the value of k. Now, we put n as 0, we'll get a1, and this a1 will be a0 plus under root of 1 plus 0, which is 1. Now we can write this one as cot pi by 4, or basically we can write this as some cot theta, where theta is pi by 4. So this a2, it will be cot theta, and plus 1 plus cot square theta is cosec theta. So there will be cot theta plus cosec theta, and this is 1 plus cos theta by sin theta, and it is cot theta by 2. If we substitute here cot theta by 2, we'll get cot theta by 2 square. So a3 will be cot theta by 2 square. So we'll get an as cot theta upon 2 to the power of n minus 1, where theta is pi by 4. Now if we find this limit, which is limit n tends to infinite, an upon 2 to the power of n minus 1 will be this limit n tends to infinite cot theta upon 2 to the power of n minus 1 upon 2 to the power of n minus 1. We will multiply it with theta and divide it with theta. So we can write this as limit n tends to infinite theta upon 2 to the power n minus 1 upon tan theta upon 2 to the power of n minus 1 into 1 by theta. Now when n tends to infinite, 1 upon 2 to the power n minus 1 tends to 0. So it is 0 upon 0 form. So now this is standard limit x upon tan x, which is 1. So value of this limit is simply 1 by theta, which is 4 upon pi. We are given that this limit is equal to k upon pi. So value of k in this is simply 4, and that is the answer to this question. Now the question is, we are given this series S, which is under root of 1 plus 1 upon 1 square plus 1 upon 2 square plus under root 1 plus 1 upon 2 square plus 1 upon 3 square up to under root of 1 plus 1 upon 199 square plus 1 upon 2000 square. Then we need to find the value of mod of 2000 into S minus 2000. Now if we write its general term, its TRth term will be under root of 1 plus 1 upon r square plus 1 upon r plus 1 square. We can write this as under root of r square, r plus 1 square plus r plus 1 square plus r square upon r square into r plus 1 square. We want to simplify this. We can write this as r to the power 4 plus r square plus 2r cube plus r square plus 1 plus 2r plus r square upon r square into r plus 1 whole square. Now it is under root of r to the power 4 plus 2r cube plus 3r square plus 2r plus 1 upon r square into r plus 1 whole square. Now if we divide everything with r square, we can write this as r square, and we'll take this 1, so it will be 1 upon r square plus, now this is 2r, and here will be plus 2 upon r plus 3 and upon r plus 1 square. Now what we'll do is we'll add 2 and we'll subtract 2, so we can write this as under root of, now this is r plus 1 upon r whole square plus 2 r plus 1 upon r plus 1 upon r plus 1 whole square. Now this is nothing but a square plus b square plus 2ab, which is a plus b whole square. So it will be this under root of r plus 1 upon r plus 1 whole square upon r plus 1 square. So it will be simply r square plus r plus 1 upon r into r plus 1. Now we can write this tr as 1 plus 1 upon r minus 1 upon r plus 1. So we have simplified this term as 1 plus 1 upon r minus 1 upon r plus 1. Now we need to find sum of first 1999 terms. We need to find sum of first 1999 terms. So we write T1, so it will be 1 plus 1 upon 1 minus 1 upon 2. T2, it will be 1 plus 1 upon 2 minus 1 upon 3. And T1999, it will be 1 plus 1 upon 1999 minus 1 upon 2000. Now if we add them all up, we'll get this resulting sum which we need, which is S. Now this is 1 plus 1 plus 1, 1999 times. So that is 1999. Now all these terms, they'll cancel. Here we get 1 minus 1 upon 2000. So this is S minus 2000. It is equal to minus 1 upon 2000. And if we cross multiply and take mod, we can write mod of 2000 into S minus 2000, it is equal to 1. So answer to this question is simply 1. Now the question is, there is a series of terms such that T1 equals 1, T2 is 5 plus 5 square, T3 is 5 to the power 3 plus 5 to the power 4 plus 5 to the power 5 and so on. Now T1 is 0, which is 5 to the power 0. T2 is 5 to the power 1. T3 is 5 cube. T4 is going to be 5 to the power 6, 5 to the power 7, 5 to the power 8 plus 5 to the power 9. So it will be this value 6. Before T1 we have 0 terms. Before T2 we have 1 term. Before T3 we have 3 terms. Before T4 we have 6 terms. So before Tn we'll have 1 plus 2 plus 3 up to n minus 1. So there will be n minus 1 by 2 terms. So for this Tn, the first term will be 5 to the power n minus 1 by 2. And then it is a GP with number of terms n and common ratio of 5. So we can write this Tn as 5 to the power n minus 1 by 2 into 5 to the power n minus 1 upon 5 minus 1. So it will be 5 to the power n minus 1 by 2 into 5 to the power n minus 1 whole divided by 4. Now we need T10. Now if we put n as 10, so it will be this 90 by 2, 45. So it will be 5 to the power 45 into 5 to the power 10 minus 1 upon 4. And that's your option 3. Now in the questions we need to find this infinite sum, which is 1 square plus 2 square by 7 plus 3 square by 7 square plus 4 square by 7 cube plus 5 square by 7 to the power 4 up to infinite. Now what we'll do is we'll write the series once more and we'll multiply with common ratio 1 by 7 and we'll shift it by one term. So it'll be 1 square by 7 plus 2 square by 7 square, 3 square by 7 cube and so on. Now we subtract second from first, we can write 6 by 7s and it will be this 1 square and then here will be 2 square minus 1 square upon 7, 3 square minus 2 square upon 7 square, 4 square minus 3 square upon 7 cube up to infinite. So it is 6 by 7s and this is 1 plus 3 by 7 plus 5 by 7 square, 7 by 7 cube up to infinite, which is nothing but an AGP. Now again, we'll use the standard process. We'll multiply it with common ratio 1 by 7 and shift it by 1. So we can write 6 upon 7 square s will be 1 by 7, 3 by 7 square, 5 by 7 cube up to infinite, and if we subtract, we'll get 36 by 49s and here will be 1 plus 2 by 7, 2 by 7 square, 2 by 7 cube up to infinite. Now this is nothing but a GP. So we can write 36 upon 49s and this is 1 plus a upon 1 minus r. So it will be 2 by 6, 1 by 3. 1 plus 1 by 3 is 4 by 3. Now this is 9. So this S will be simply 49 by 27. So sum of the series is 49 by 27 and that's your option C. Now the question is, a child was asked to add the first few natural numbers, that is 1 plus 2 up to 3, so long as his patience permitted. When he stopped, he gave the sum 575. When the teacher declared the result wrong, the child discovered that he had missed one number in the sequence during addition. The number he missed was. Now, if the child has added all the numbers from 1 to n, its sum would have been n plus 1 by 2. And suppose the number he has left out is a, and this sum is now 575. So what we'll do is, rather than finding this a, we'll find a number which is closer to 575. Now this is n square plus n minus 1150 equals 0. So the value of n which is closer to this sum, it will be minus 1, we'll take plus sign and then it will be 1 plus 4 into 1150 whole divided by 2. Now 1150 into 4, it is 4600 plus 1. Now under root of this value is 0.678, so it will be nearly minus 1 plus 67.8 divided by 2, which is nearly 33.4. Now this a is n plus 1 by 2 minus 575. When n is nearly 33.4, the value of a is 0. Now this a, it must be positive. So the value of n that we need to take is the integer which is greater than 33.4. So we'll take n as 34, and if we take n as 34, it will be 17 into 35 minus 575, and which is 20. So the number that was missed by the child is number 20, and that's your option 3. Now the question is, the inverse of sum of the following series up to n terms can be. Now, basically, I think we need the sum of the following series up to n terms. So we given this series, which is 3 by 4, 5 by 36, 7 by 144 up to n terms. Now this is 2 square, this is 2 square into 3 square, this is 3 square into 4 square. So its general term will be 2r plus 1 upon r square into r plus 1 square, which we can write as 1 upon r square minus 1 upon r plus 1 whole square. Now sum of n terms will be this first term plus this second term, and then this nth term. Now if we add them all up, we'll get this sum as 1 minus 1 upon n plus 1 square. Now this is n plus 1 square minus 1 upon n plus 1 square. Now this is n square plus 2n upon n plus 1 whole square, and that's your sum, and that's your option 3. Now here the question is, find the value of this sum, which is this summation k varies from 1 to infinite. This sum n varies from 1 to infinite k upon 2 to the power of n plus k. Now here the variables are independent, so we can write k varies from 1 to infinite k upon 2 to the power k into this summation n varies from 1 to infinite 1 upon 2 to the power n. Now this is an AGP and this is a simple GP. If we solve this GP, it is 1 by 2. 1 by 2 square, it is an infinite GP. First term is 1 by 2. Common ratio is also 1 by 2. So value of this summation is simply 1. And if we solve this AGP, this sum, it is 1 upon 2, 2 upon 2 square, 3 upon 2 cube, and we write s by 2 as 1 upon 2 square, 2 upon 2 cube, and we subtract, we'll get s by 2, and this is 1 by 2 plus 1 by 2 square plus 1 by 2 cube, which again is a GP whose sum is 1. So value of this sum is simply 2, and that's your option D. Now here the question is, we need to find sum of this infinite series, which is 1 by 9 plus 1 by 18, 1 by 30, 1 by 45, 1 by 63 up to infinite. Now we can take 1 by 3 common. So it will be this 1 by 3, 1 by 6, 1 by 10, 1 by 15, 1 by 21. Now this is 1 by 3, and this is 1 into 3. This is 3 into 2. This is 5 into 2. This is 5 into 3. This is 7 into 3. Now what we can see is, here we have 1, 3, 3, 2, 5, 2. So we can write this as 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. So we'll multiply by 2 and divide by 2. So we'll write 2 by 3. And this is 1 upon 2 into 3, 1 upon 3 into 4, 1 upon 4 into 5, 1 upon 5 into 6 up to infinite. So it will be this 2 by 3, and this is 1 by 2 minus 1 by 3, 1 by 3 minus 1 by 4, and this series it continues up to infinite. So answer to this series is simply 1 by 3, and that's your option A.